This video is on the composition of functions, which is located on the bottom of page 4 and all of page 5 in your 4.7 notes. So recall back from chapter 1 when we did a composition of functions relating to the inverse functions. We said that if we calculated f of f inverse of x and it equaled x, and f inverse of f of x and it equaled x, then f and f inverse were inverses of each other. So we're going to see compositions of functions in terms of trigonometric functions. It's going to look fairly complicated, but we're going to break it down where we're going to evaluate the inside portion or that inside function first, and then apply the outside function. If you were to not do it this way, you could remember some of these hints. So if you had sine of the arcsine of x, it's equal to x, or the arcsine of the sine of y is equal to y. Same thing for cosine and tangent. This is really only helpful for tangent and arctangent, and that's because tangent is defined by all real numbers, whereas the other ones have those restrictions to them. So if you do have a tangent of an arctangent, you're able to essentially cancel those out because it's always going to be defined. But for sine and cosine, you're going to see that we do have to make some adjustments based off of the quadrants that we are defined in. So looking at the top of page 5, our first example is the tangent of the arctangent of -5. So we don't know what angle measure has a tangent of -5 to evaluate that inside function. However, because we're taking the tangent of the arctangent of -5, they essentially just cancel each other out because they're inverses of each other. So our answer is -5. Again, that's always going to work for tangent. It can work for some sine and cosines, but it's always best to evaluate them out just in case. So for example, in number 2, the arcsine of the sine of 5 pi over 3 does not equal 5 pi over 3. So let's see why that is not the case. So the first thing we're going to do is evaluate this inside function here. What is the sine of 5 pi over 3? So we look on our unit circle and we see the coordinates of 5 pi over 3 are 1/2 and -√3 over 2. Therefore, the sine is just the y value of that. That's just -√3 over 2. So we're able to simplify this function down. So instead of finding the arcsine of sine of 5 pi over 3, the sine of 5 pi over 3 we can replace with -√3 over 2. And now this is exactly like one of the functions you saw in the previous part of chapter 4.7. We're finding what angle measure has a sine of -√3 over 2. So remember, arcsine is defined from -pi over 2 to pi over 2. So we're seeing what angle measures have a y value of -√3 over 2. That's going to be down here. So again, normally we would call that 5 pi over 3, but because we're in arcsine, we now have to call that -pi over 3. So our answer is -pi over 3, not 5 pi over 3. And looking at number 3, we want to find the cosine of the inverse cosine of pi. So the first thing we're going to do is evaluate this inside function. What is the inverse cosine of pi? So what that's asking is saying what angle measure has a cosine of pi. So we know we have an angle of pi, but this is like a 3.14. So where on our unit circle do we have an x value of 3.14? That doesn't exist anywhere. Remember, our unit circle for our x values only go from a -1 to a +1. So 3.14 is too big. Now, if this were the inverse cosine of the cosine of pi, then it would be a different story. We would be able to identify that. However, because this is the cosine of the inverse cosine of pi, we first have to see what angle measure has that cosine of pi. Pi is not a possible x value, so that is no solution. So that's a tricky one. Looking at number 4, we have the arcsine of the sine of 3 pi over 2. So again, we're going to evaluate just this inside portion first. So the sine of 3 pi over 2, think of your coordinates there. Those are 0 and -1. So the sine of 3 pi over 2 is just -1. Now that we've evaluated that, we have to see what angle measure between -pi over 2 and pi over 2 has a y value of -1. That's happening down here at that -pi over 2. So therefore, again, our answer is not 3 pi over 2. Oops. Our answer is not 3 pi over 2, but it is -pi over 2. Now, sometimes it's going to be helpful to draw right triangles to find the exact values because we are outside of the unit circle. So looking at number 1, we have the tangent of the arc cosine of 2/3. So notice that these aren't going to cancel out. It wasn't like in our previous section where we had inverse cosine of cosine or the inverse sine of sine. Here we've got the tangent of the inverse cosine. So this 2/3, there's no angle measure on our unit circle that has an x value of 2/3. That means we are outside of our unit circle. So think back to a previous section where we had to determine that radius. So remember cosine, that is x divided by r. So we know our x value is 2, our our r value is 3, and we have to use our Pythagorean theorem here to find that y value of root 5. If you want to draw a right triangle as well, that could be helpful. So if you place your right triangle and you place your theta somewhere, and you know cosine is adjacent over hypotenuse, so therefore 2 is my adjacent side and 3 is my hypotenuse side. And again, you're using your Pythagorean theorem to find that missing side length. In this case, it's the opposite side. So you can either think of this as x, y, and r, or you can think of this as opposite adjacent and a hypotenuse. In either case, you'll get the same answer. So now we want to find the tangent of this information. So the tangent is going to be root 5 over 2. So if you're thinking in terms of x, y, and r, your tangent is y divided by x. So that's where we get root 5 over 2. If you're thinking in terms of your right triangle, tangent is opposite over adjacent. Again, we get that root 5 over 2. Looking at number 2, we want the cosine of the arcsine of -3/5. So you can go about this in the exact same way we just did. You can make x, y, and r. Sine is y divided by r and continue that way. You can make a right triangle. However, because I have this negative sign, it might be helpful for you to put it on your xy axis. So another way of looking at this, again, you can do this problem exactly how you're used to and using x, y, and r. I'm just showing you a different method. Think back to where arcsine is defined. So remember, the inverse sine is defined in quadrants 1 and 4, from -π/2 to π/2. However, since we're looking at a negative value, that means we're down in quadrant 4. So our answer is going to be between -π/2 and π/2 for some angle measure. Therefore, when I draw my right triangle, I just know I'm in quadrant 4 somewhere. So you can draw a triangle facing down like this, place your theta in an angle, and then you could make your opposite side, or in this case, the y value going down is -3. The hypotenuse is 5. And then again, you're using your Pythagorean theorem. So 3 squared plus what gives us 5 squared? That is 4. And we know we're going to be positive because we're in that positive x direction. Again, you could answer this the same way, doing x, y, and r, listing those if you're more comfortable that way. If you wanted to draw a triangle, I would suggest knowing what quadrant you're in so you know what value is negative. So here we want to find the cosine. Cosine is adjacent over hypotenuse, so therefore our cosine is 4/5. Might be a good time to pause the video and try numbers 3 and 4 on your own in a method that works best for you. Again, either using x, y, and r, or drawing your right triangle in your quadrants. And then start the video again to see if your answers are correct. I'm going to show the work using triangles in the quadrants, just like in number 2. Hopefully you've had some time to try out numbers 3 and 4. The answer for number 3 is -5/13. And number 4 is 4√7/7. So let's see again why that's the case. So number 3, the first thing I want to evaluate is this inside portion. And again, I know my arctan is defined in quadrants 1 and 4, but because it's negative, I'm going to be down in quadrant 4. So when I go and make my right triangle, if I place my theta somewhere, tangent is opposite over adjacent, so I have my opposite side over my adjacent side. Pythagorean theorem shows us that the hypotenuse is 13, and from here I can find my sine is opposite over hypotenuse, which is where we get that -5/13. Again, you could also think as tangent as y divided by x. Just make sure you know which is positive and which is negative in that case. Because you're in quadrant 4, that y value must be negative. So I do suggest drawing your right triangles for these, or again, going through that ASTC that we've done before. And then in number 4, so again, we're looking inside, looking at arcsine of 3/4. So because arcsine is also defined in quadrants 1 and 4, but arcsine is positive, that means we can draw our triangle in quadrant 1. Placing our theta somewhere, my opposite side is 3, my hypotenuse side is 4, or again, think of it as y divided by r. My y is up and down. My radius is that hypotenuse there, and using the the Pythagorean theorem will give us that x value of root 7. So now we want to find the secant of all of this information. So I like to find what its reciprocal is first. The reciprocal of secant is cosine. So the cosine is root 7 over 4, meaning that the secant is its reciprocal for root 7 over 7. I will be posting some extra practice problems online for you to complete, and I will post my solutions to those online as well for you to check your work.